Welcome to the electrical power system. Today we will talk about cross-sectional area, resistance, and resistivity. First, we define the resistance. What is the resistance of conductor? The resistance of conductor is the opposite of current flow in the circuit. So anything causes the opposition of current flow in the circuit is called resistance. The resistance is equal rho times L divided by A, which R is equal rho times L divided by A, which R is represent to the resistance of conductor, and rho is the resistivity of conductor. L is the cable length, and A is the cross-sectional area of conductor. Secondly, what is the resistivity? The resistivity is the characteristic of each material on a basis of how well electric current flow in them, and it takes the symbol of rho. So we have a table of conductor resistivity, which you have a tungsten is equal 5.6 times 10 to the minus 8 ohm per meter, and silver is equal 1.59 times 10 to the minus 8 ohm per meter. Copper is equal 1.68 times 10 to the minus 8 ohm per meter, and gold is equal 2.44 times 10 to the minus 8 ohm per meter. Aluminium is equal 2.82 times 10 to the minus 8 ohm per meter. This is the resistivity of different type of material. So here we have a problem. This problem is what is the resistance of silver wire that is 20 meter length, and it has the diameter of 4 millimeter. So from our rule, R is equal rho times L divided by A, and the resistivity of silver is equal 1.59 times 10 to the minus 8, and we know that cross-sectional area or area of circle is equal pi r square. R is the radius of the circle, so the radius is equal diameter divided by 2. So here we have a diameter of 4 divided by 2 is equal to millimeter. So from our rule here, the resistance is equal rho times L divided by cross-sectional area. So rho is equal 1.59 times 10 to the minus 8 times 20 divided by pi multiplied by 2 times 10 to the minus 3 square. So from our calculator, the answer is equal 4 ohm. Number 2, copper conductor. In the building that has a radius of 2 millimeter, what is the length of conductor would have a resistance of 0.5 ohm. So from our rule, R is equal rho times L divided by A. So from this rule, the length or L is equal R times A times cross-sectional area divided by the rho. So here we have cross-sectional area is equal pi r square, and L is equal, so our resistance is equal 0.5 times cross-sectional area pi times 2 times 10 to the minus 3 square divided by the rho. rho of copper conductor is equal 1.68 times 10 to the minus 8. So from this calculator, then the answer is equal 374 meter. This is the length of our cable. Okay, number 3. What is the cross-sectional area of tungsten conductor that has a length of 10 meter and resistance is 2 ohm? So from our rule also, we know that the cross-sectional area here is equal R times L divided, or rho times L divided by the resistance, and the resistivity of a tungsten is equal 5.6 times 10 to the minus 8. So here cross-sectional area is equal, rho is equal 5.6, 0 times 10 to the minus 8 times length of cable here is equal 10 meter divided by the resistance of 2 ohm. So area is equal 0.0000228 meter square. So here the resistance is equal, or the radius is equal A divided by pi. So the answer of the radius here is equal 0.0095 millimeter. So what is the diameter? The diameter is equal 2 multiplied by the radius of this cable, and we have the radius here. So the diameter is equal 2 multiplied by the radius, and this is our answer is equal 0.019 millimeter. Last one. What is the resistivity of wire that has 10 meter length with a diameter of 3 millimeter and resistance is 2 ohm? Here we don't know the type of material, so we don't know the resistivity of this material. We need to calculate the resistivity of this material. So from this our rule here, the resistivity rho is equal R times A divided by the length of cable, and we have the length is equal 10 meter and A is equal pi R square. So we have R is equal diameter divided by 2, the diameter divided by 2. So we have 3 divided by 2 is equal 1.5 times 10 to the minus 3 square. So here rho is equal R, which is 2 ohm, multiplied by the cross-sectional area. This value is equal 1.5 times 10 to the minus 3 square. So divided by the length of cable. Length of cable here of our wire is equal 10 meter. So our answer is equal 1.412 times 10 to the minus 6 ohm per meter. Thank you for watching, and don't forget to subscribe our channel.